This is problem number 37 in section 7.1, still completing the square. Remember, again, that what we're trying to do is get an equation in the quadratic standard form, which is ax squared plus bx plus c is equal to 0, where x is a first degree exponent. This is number 37, so each one of these problems I've chosen here has a little bit of something new in it. In this particular problem, check this out. What we have is, of course, we need to have like denominators, but these are conjugate bases here. These are conjugate pairs of these two. So as it turns out, what we're going to do is multiply each one of these by a form of 1, but it's going to be a conjugate, which is kind of nice. Now, I'm also going to draw attention to this over here in a second, this denominator. So we have x over x minus 1 times a form of 1, which is, in this case, it's going to be x plus 1 over x plus 1. Now, this is minus x over x plus 1. Now we're going to, of course, use the conjugate base here in a form of 1, and this will be x minus 1 over x minus 1, which is all equal to the same thing, because we haven't done anything to add over here. So this is the same amount, the same quantity over here, 2x squared all over 1 minus x squared. Now, again, pay attention to this, because what this adds up to is, I'm going to distribute here, and I'm going to distribute here, and I'm going to get x squared plus x all over this product. Now, these are conjugate pairs, so this is x squared minus 1. Minus, distribute correctly, x squared, negative times a positive is plus, this, we're not going to do that yet. X times x is positive x squared. X times minus 1 is, is minus x all over x squared minus 1, and this is equal to the same amount. Now, let's look at this, and this is something that SATs will try to do with you. And remember, as you guys have heard me say many times, SATs try to trick you. If you set your eyes on this, you go, wow, there's something unique about that. I can, if you look up here, I can take a negative 1 out of this, and I'll get x squared minus 1. Look at this. Minus 1 times x squared is negative x squared. Minus 1 times minus 1 is positive 1. So if I factor that out, and then I can put that negative in front of this whole expression. So what we get here, this is the second step. Third step, let's combine all this numerator stuff here. So x squared minus x squared is gone. X minus a negative x is 2x. That's what results in the numerator. And this is x squared minus 1 is equal to 3 minus, because I've factored this out, 2x squared. Now remember, because I did this, this is now very convenient. This is x squared minus 1. Note, that's what we like. Bring this to the other side now. Let's add 2x squared over x squared minus 1 to both sides. So in the fourth step here, we get 2x over x squared minus 1 plus 2x squared all over x squared minus 1 is equal to 3. Okay, great. Now, we're going to go to step 5 here. Now, we're going to combine this, and we have 2x squared plus 2x all over x squared minus 1 is equal to 3, which is really 3 over 1, because I'm going to cross multiply. 3x squared minus 3 is equal to 2x squared plus 2x. Now, back to the standard equation. Let's write it that way. Let's subtract 2x squared from both sides, and we're left with, by the way, this is step 6, let's say. So we have x squared, add 2x to both sides. And by the way, I'm sorry, guys, this is 3 here. So subtract 2x, and this is minus 2x. And let's take 3 to the other side, so this is 3. Now, we can complete the square. So step 7 is really doing what we're asked to do here. We have x squared minus 2x. Now to complete the square, divide the b term by 2. Negative 2 divided by 2 is negative 1. Squared is positive 1. And if we add positive 1 over here, we have to add it over here. So 3 plus 1, which is equal to 4. Now, that means step 8, factor this. X minus 1 squared is equal to 4. Take the square root. Step 9, x minus 1 is equal to plus or minus 2. Therefore, x is equal to 1 plus or minus 2. Now, if you always do as you should do, check some answers into this problem. This comes up with 1 plus 2 is 3, or 1 plus a negative 2 is negative 1. Now, if you take negative 1 and put it into one of these, you'll see that you get 0 in the denominator, which means that that doesn't work. Your singular answer is positive 3. You guys have asked for a couple of problems on section 1, page 310. So here's 35, and I did this in class with you guys. So let's work on this a little bit. So I've written the problem out here. It's 1 over y plus 2 plus 1 over y plus 6 equals 1. Now, just as a reminder here, that the standard quadratic equation up here is ax squared plus by plus c is equal to 0. It is in a quadratic equation because it's a second degree equation, in which case we are going to have the coefficient a in front of the squared term, the coefficient b in front of the x term, which is to the 1, and c, which is a constant. And the process that we're going to do here is completing the square. So looking at this equation over here, what we see is that the problem in this problem is that we have denominator and they are different. So we cannot add these. So we need to get similar denominators or the same denominators. So we need to take this and multiply it by a form of 1, which in this case is y plus 6 over y plus 6. And again, remember that this is a form of 1 plus 1 over y plus 6. And we need to multiply this by a form of 1, but we're going to use the other one over here, y plus 2. So y plus 2 over y plus 2. Now some of you get confused on this. All we're doing is multiplying this by a form of 1. Therefore, we haven't changed it. We've changed it in form, but in value we have not. That is the reason that on this other side, this still remains 1. We don't add anything here because we haven't, in effect, added anything on the left-hand side. We've just changed the form. So multiplying here, numerator times numerator, denominator times denominator, we now get, and I'm going to say this is first step, second step, third step, so maybe it's a little easy to follow here. So we get y plus 6 over y plus 2, make this a y here, times y plus 6 plus numerator times numerator, denominator times denominator, y plus 2 over the common denominator, y plus 2 times y plus 6, which is the common denominator, and that's equal to 1. So let's add, now we can add this numerator. So fourth step here, we get y plus 6 plus y plus 2 all over, now I'm going to expand this, y squared plus, now what do we get in the middle here? We get y times 6 and y times 2, so this is 8y, and 2 times 6 is plus 12 is equal to 1, which is really 1 over 1. Fifth step, I'll crowd in here. Now let's combine everything in the numerator, so we get 2y, that's that and that, plus 6 and 2 is plus 8, all over y squared plus 8y plus 12. And I'm going to scoot over here to step 6. I'm going to have to write a little smaller here. So this is, by the way, this is equal to 1, which is really 1 over 1. Now I'm going to cross multiply here. And I'm going to write this cross multiplication over here in step 6. So I get 2y plus 8 is equal to y squared plus 8y plus 12. Step number 7. Let's combine, and I'm going to combine a couple of steps here. I'm going to put the squared term and the bx term together, and I'm going to put the constant on the right hand side. So if I do that, I am left with bringing 12 over here. I'm left with minus 4 is equal to y squared plus 6y, and I've already brought 12 over here. Now complete the square. So I'm just going to rewrite this, y squared plus 6y is equal to negative 4. Now completing the square, we get y squared plus. Now to complete the square, take the coefficient of the b term, divide it by 2. 6 divided by 2 is 3. Square it is 9. So we've added 9 here. So we need to add 9 to a negative 4, which is 5, positive 5. Now, in step 9 here, we can now say that this is y plus 3 squared is equal to 5. Take the square root of both sides, we get y plus 3 is equal to rad 5. So y is equal to negative 3 plus or minus rad 5. And as it turns out, that's the answer in the text. And you want to make sure, since we have two numbers here, to check both into the equation to see that both work. And that's how to do number 35.